This lesson is on systems of equations. We're going to look at the best way to solve a system given the options of graphing, substitution, or elimination. We're going to look and see which is going to be the easiest to use when. So it's going to be easiest to graph a system, and when we're going to use this is when both equations are in slope-intercept form. When both equations are in slope-intercept form. That's going to be the easiest. Remember, slope-intercept form is y equals mx plus b. All right. Typically, you'll have a calculator, more than likely. On the off chance that you don't, we know when we have two equations in slope-intercept form, they make two lines on my graph, so I can just go ahead and graph those lines and see where they intersect. All right, so we have our slope and our intercept. Our slope in the first equation is -1, and the intercept is 3. So let's start there. Start at 3. Follow slope. Slope is negative, so I'm going to go down 1, right 1, down 1, right 1, and you can continue, or up 1, left 1. It's all the same. Okay, and then you can draw your line. Then we're going to graph our second equation. Our slope in the second equation is 2, and our intercept is -3. Start at your intercept on the y-axis. Slope is 2, so 2 over 1. Rise 2, right 1. Rise 2, right 1. Oh, and that's where it intersects. So I can just draw that line. The solution to this system is where they intersect, which is at 2, 1. That is the solution. You could also plug that into your calculator and check for that point of intersection. All right, let's do the next one. I have my first line, my slope is 1/3, and my intercept is -5. So go ahead and graph that. It's a positive 1/3, so rise 1, right 3, or down 1, left 3. And my second equation, my slope is 3/2, or 3 over 2, and my intercept is 2. Start at the B, begin at B, rise 3, run 2. They're both positive, so I'm going up and to the right, or down 3 to the left 2. Negative over a negative is also a positive. And there's my point of intersection. That point is left 6, down 7, so -6, -7. So that's graphing. It's going to be the easiest to graph when both of those lines are already in slope-intercept form, or when it's going to be very easy to get both of those equations into slope-intercept form. All right, so for substitution, the best time to use substitution is when one equation has x or y isolated, or just alone, on one side of the equal sign, and the other does not. The other equation does not. So in this problem here, in this example, I have y equals 2x plus 3. I have an isolated variable. The variable that's isolated is y, which is 2x plus 3. It's going to be easy to substitute into that bottom equation. So 4x not plus y, 4x plus the 2x plus 3 equals 21. I don't have to distribute anything because there's a positive 1 there. It's all the same. 4x and 2x are my like terms. 6x plus 3 is 21. Subtract 3 from both sides, or VC. 6x equals 23. Excuse me. 21.
May I have your attention, please? At this time, we need 6th grade students qualifying for the AR celebration. Please report to the cafeteria.
And then we're going to subtract 3 from it because I'm bringing it over, making it a negative. So 6x equals 18. Divide both sides by 6. X is 3. I'm going to need that in my final answer. But then I'm going to substitute back in again 4x, because that's what I found. It's going to be easiest to put into that top equation, since y is already isolated. 2 times 3 plus 3. Y equals 6 plus 3, which is, where am I? 9. So 3, 9. Okay. Don't forget, I also could have easily solved for this y by taking that 4x and subtracting it from both sides. So I could have graphed that one if I put that in slope-intercept form as well. The next one, I have a variable isolated all by itself. It's y, so I'm going to plug that into y in that second equation. X plus 2, not times y, times x plus 4 equals 11. Distribute the 2 to everything inside the parentheses. I'm left with x plus 2x plus 8 equals 11. So 3x plus 8 equals 11. Subtract 8 from both sides. So 3x equals 3. And divide by 3. X
At this time, we need 7th grade students qualifying for AR celebration. Please report to the cafeteria.
Now what I have is my x, and I have to substitute back in to find my y. It doesn't matter which equation I'm putting it in, but since y is already isolated there, that's going to be much easier for me. So y equals 1 plus 4, which is easy. Y is 5. So my solution is 1, 5. And now elimination. The best time to use elimination is going to be when both equations are in standard form, which means that x and y are lined up. When both equations are in standard form, so that means that x and y are lined up. As you can see, all of these equations are already in standard form. If you don't remember what standard form is, it's when it's called ax plus by equals c. That just means there's a coefficient with x, a coefficient with y. Don't forget the coefficient could be 1 or negative 1. And then there's that constant is on the other side of the equal sign. So then I'm going to look to see, is there anything that I can immediately cancel out? There's a 2 and a 4 and a 3 and a 2. No, there's not. I can't make a 2 into a 4, but I can make a 4 into a 2 easily. But I'm going to need it to be the opposite sign. So I'm actually going to need this to be a negative 4. How do I make that into a negative 4? I'm going to have to multiply the entire thing by negative 2. So then I have negative 4x plus 6y equals negative 6. And then I'm going to
May
bring
I have your
that
attention,
bottom
please,
part
at
over.
this time? 8th grade
4x
students participating in the AR celebration. Please report to the cafeteria.
I have my opposite sign, so I'm going to add to zero it out. 6 plus negative 2y is 4y equals negative 6 plus 10 is 4. Divide, y is 1. Plug it back in to solve Doesn't matter which equation you put it in, you have 4 options. I'm typically going to pick one of the originals because I multiplied, so those numbers are bigger than they needed to be. Okay, so I'm going to plug it back into, let's say, the first equation. 2x minus 3 times 1 equals 3. 2x minus 3 equals 3. Add 3 to both sides. 2x equals 6. And divide x equals 3. So 3, 1 is my solution. And then the next one, I have nothing that I can easily cancel out. If I was going to make these x's the same coefficient, I would have had to multiply both. I really don't feel like doing that. Instead, I can easily turn this y into a 10y, and I really want it to be a negative 10y so that they're opposite signs. So I'm going to multiply the whole bottom by negative 10. So I then have negative 30x, positive 30x, negative is a positive, minus 10y equals negative 100. And bring over what was on top. I had 4x, a positive 10y, and a negative 2. My y's are opposite signs, so I'm going to add 4 plus 34, is 34x. 10 plus negative 10 zeroes out, and then equals negative 102. Negative 2 plus negative 100 is negative 102. Divide both sides by 34. X equals negative 3. Plug it back in. Doesn't matter where you go with it. Maybe the top one, both of them have a negative in it somewhere. 4 times negative 3 plus 10y equals negative 2. Negative 12 plus 10y equals negative 2. Add 12 to both sides. 10y equals 10. And divide y is 1. Negative 3, 1 is my solution. And then the last one. I don't have anything that's already same coefficient with an opposite sign, but I can turn this 3 into a 6, and I want it to be positive 6 because the bottom one's already negative. So I'm going to just multiply by a 2. And then I'm left with 6x minus 8y equals negative 4. And I'm done with the top equation. Different signs or opposite signs I'm going to add to cancel it out. I'm left with negative 3y equals 3. Divide both sides by negative 3. Y is negative 1. And then plug it back in. Okay, so then we have 3x minus 4 times negative 1 is negative 2. 3x plus 4 is negative 2. Subtract 4 both sides. 3x equals negative 6. And divide by negative 3. X is negative 2. The code word for this lesson is whistle, because I have my whistle right here. On your left-hand page, I want you to do, let's say evens. I want you to do evens on the left-hand page, and then we'll work on odds in class. If you want to go ahead and get started on that, you may. I really want you guys to choose whichever method you want to solve these. I gave you helpful hints for each, which one's the best time to use what, but it does not ever matter to me which method you're using to solve a system.